Today we are going to study an important chapter from 12th chemistry. The name of this unit is solid state. In this chapter, we will understand what solids are, how they are different from liquids and gases, and how particles are arranged inside solids. We will learn everything step by step in a simple and clear way. Can you recall? Let us begin by recalling some basic ideas. The first question is, what are the three most common states of matter? The answer is solid, liquid, and gas. Now the next question is, how does the solid state differ from liquid and gas? We can understand this by comparing them using a few important points. First point is volume. Solids have a definite volume. Second point is shape. Solids have a definite shape. Third point is effect of temperature and pressure. When temperature or pressure changes, solids show only a very small change as compared to liquids and gases. Fourth point is motion of particles. In solids, particles remain at fixed positions and only vibrate about their mean positions. Fifth point is interparticle forces. The forces of attraction between particles in solids are very strong compared to liquids and gases. 1.1 Introduction. As studied earlier, the solid state of matter is characterized by strong interparticle forces of attraction. Because of these strong forces, solids have a definite shape and a definite volume. Even when temperature and pressure change, the shape and volume of solids change only slightly. Now let us understand what the smallest constituent particles of solids can be. The smallest constituent particles of solids may be atoms, ions, or molecules. In this chapter, all these smallest constituent units will be referred to as particles. Important note for students: particles in solids are not free to move from one place to another. They can only vibrate about their mean positions. 1.2 Types of solids. On the basis of the internal arrangement of particles, solids are classified into two main types. The first type is crystalline solids. The second type is amorphous solids. Observe and discuss activity. Now let us understand an observation-based activity. Suppose we collect the following solids: granular sugar, common salt, and blue vitriol. When we observe these solids under a magnifying lens or a microscope, we notice some common features. The shape of the granules is definite and regular. The faces of the granules are smooth and flat. The angles between the edges are fixed and characteristic. From these observations, we can conclude that these solids have a regular internal arrangement. Therefore, these solids are called crystalline solids. The observed properties of crystals are as follows. They have a definite geometrical shape. They have smooth faces. They have fixed interfacial angles. Particle arrangement. Now imagine a solid in which particles are arranged in a definite pattern. In the diagram, two different types of circles represent two different types of particles. These particles are arranged in a repeating pattern. Let us answer the following questions. First question: is the arrangement of particles regular or irregular? The answer is, the arrangement is regular and periodic. Second question: is the arrangement of particles the same along different directions, such as direction AB, direction CD, and direction EF? The answer is no. The arrangement of particles is different along different directions. This directional dependence of properties is an important feature of crystalline solids. 1.2.1 Crystalline solids. Now let us study the characteristic properties of crystalline solids. The first property is long-range order. In crystalline solids, particles are arranged in a regular and periodic manner. This ordered arrangement extends over a large distance throughout the crystal. The second property is sharp melting point. Crystalline solids melt at a definite temperature. The third property is anisotropy. Physical properties such as refractive index, thermal conductivity, and electrical conductivity vary with direction. A property measured along one direction may be different from that measured along another direction. Examples of crystalline solids include ice, sodium chloride, metals such as sodium, copper, and gold, diamond, graphite, and ceramics. Remark: except for crystals having cubic structure, most crystalline solids show anisotropic behavior. 1.22 Amorphous solids. Amorphous solids can be considered as supercooled liquids. Let us understand their main characteristics. The first characteristic is random arrangement. In amorphous solids, particles are irregularly arranged. They do not show long-range order, but only short-range order. The second characteristic is no sharp melting point. Amorphous solids do not melt at a definite temperature. They gradually soften over a range of temperature and slowly start flowing when heated. The third characteristic is isotropy. Physical properties of amorphous solids are the same in all directions. Their properties do not depend on the direction of measurement. Examples of amorphous solids include glass, plastic, rubber, tar, and metallic glass. An important extra idea to remember is that when glass breaks, it does not break into regular shapes. This shows the absence of a regular internal arrangement. Do you know? A single crystal has a regular and periodic arrangement of particles throughout its entire bulk. Most crystalline solids are polycrystalline in nature. A single granule of a polycrystalline solid consists of many small crystals called crystallites. Each crystallite has a different orientation. Single crystals are difficult to obtain. Diamond is an example of a naturally occurring single crystal. Daily life example. Consider sugar and glass. Sugar crystals have a fixed shape and a sharp melting point. Glass, on the other hand, softens slowly when heated. Sports-related example. On a cricket ground, fielding players stand at fixed positions. This arrangement is similar to particles in crystalline solids. The moving crowd in the stadium represents the random arrangement of particles in amorphous solids. Daily life analogy. Students sitting in a classroom, according to roll numbers, represent crystalline solids. During recess, when students move freely without fixed positions, they represent the nature of amorphous solids. This completes the student-friendly English narration for Unit 1 Solid State.